Hi, I'm Tom and I talk about code. Welcome to another PlayStation 2 game hacking live stream. In the last two streams, we've played around with injecting code into Kingdom Hearts on the PlayStation 2. I have a couple of tools that I wrote off stream for injecting code, for patching the game binary, repackaging it into a full disk image. That all works really well. Today, well, actually, I did a little bit of work off camera that's probably worth showing off. Let's get rid of that tab. That's not something I want to show on stream. And let's have a look at what I did off camera. So, the first thing I did was a little change to a PRNG function that I wrote, because if we're doing a randomizer, we're going to need random numbers. Bobius, welcome. Last time I wrote this, I put it up the top of the file, and that's a problem because the way that this assembly is going to work, it's going to run top to bottom. So we're going to put all our functions at the bottom. Also, I forgot to put a jump at the end, so that we just fell out the bottom of this. So now you call this like a function. There's no like stack frame or anything, but you need to be able to jump back to the place that called it. So we jump and link, that puts the program counter in the RA register, and then we jump back there at the end. Xlinks, welcome, come in. How are you guys going? What's been happening in the world of programming? And you guys been working on anything cool? So I have... Now, before we do anything else, we store whatever the return address was when we enter my little assembly hook. We push that onto the stack, and then the last thing we do is pop it back out, so we restore this register back to where it was. And then inside here, we only ever touch these temporary registers. So this is cool. This is a little bit like what I was starting to do when I was trying to do this with C, and I was trying to have this like preamble that stored an entire, the entire state, and then refreshed it so that we didn't corrupt future function calls. But it's actually kind of easier to do this in assembly because we control the order of things a lot more. We can just put data down in whichever order we want. We can put code down in whichever order we want. We don't have a compiler that's going to try and wrestle control of that from us. So, wonderful. There was another thing I did. Oh yeah, I've just added a little bit of extra data into here. I played around with actually seeding the random number generator. We'll eventually find a address in memory that changes every time the game runs to seed this from, but for now, we're just going to pick a number. There was something else, maybe? No, this looks like about it. But yeah, so basically this works now, right? We generate a random number, that was it. I was talking about modulo, and I worked out that actually I don't want to do a divide or anything fancy. I just want to AND my randomly generated number with a mask, because the randomly generated number is a full 32-bit word. So the chance of any bit being on or off is random, so masking this with hexFF is the same as taking the modulo 255. We shift that left by 4. This generates a chest table entry that's going to give us a random item between 0 and 255. Let's run the game and see what state that's in. So to run this, oh yeah, I changed a little bit in how this builds as well. That's not particularly interesting. I cleaned up my make file. So I build this as a binary. These warnings are okay. We're going to ignore these warnings. That's fine. And then I'm going to fast equals 0 dash. I'm going to apply the binary patch to the game, and I'm going to run the newly patched game. Bobius in chat says, spend a bunch of time reading through BDWGC. Windows... What is BDW? I don't actually know what that is. Never heard of this before. I probably have heard of it before. It doesn't come to mind. PCSX2 QT. We're going to run my patched game image. This always takes a second to load, which is, going to add up over time. Don't know why the screen is black here. That was a bit weird. Strange little graphical issue. Do we have music? Yeah, we got a little bit of music. Do we have controller? We don't have controller. Was my controller plugged in? Okay, controller connected. Controller not talking to computer. I'm going to restart the emulator and just see what happens. While this kicks off, let's have a look at this shady link. BDWGC. Oh, BOMGC. Okay, I have actually heard of this. I've heard people say BOMGC. So this is like used places. Plugin replacement for seasonalloc. Yeah, cool. Cool. Okay, why do I have no controller life? That's a bit weird. This was working yesterday. This has been controller. No life. I'm pressing buttons. So that's cool. That's not the kind of thing I want to be troubleshooting. Let me try plugging it into a different port. Okay, we've plugged it into a different USB port. That's always a good troubleshooting step. Weirdly, the LED on this starts blinking. This is a PlayStation 3 controller, by the way, so it's always a bit jank. But the LED on this starts blinking once the game runs, which doesn't feel right. And you can see there's no life. Okay, well this is fun. This is gonna get cut out of the VOD. I could try my other PS3 controller. Just a sec. I'm gonna go get my other PS3 controller and see if this works. I don't have many controllers that I plug into computers. One second. Alright, that works this time. I've got this is a fake DualShock 3 controller. I bought it thinking it was a real DualShock 3 controller, but it's a fake controller, but for some reason the fake controller succeeds, where the real controller fails. So let's have a quick look at what my randomizer currently does, if I unpause the game. Whoa. Well, it's not meant to do this. That's pretty funky. So it's not, okay, this is like, surely this is a my computer problem and not, what the hell? That's like a weird Z buffer issue. I don't know why, okay, hold on. Whoa. Let's do my favorite thing and get rid of the instruction where we actually store a word. Let's rebuild this. Let's repatch the binary. And let's run that again and just see if that is consistent. If this is a GPU driver issue, I might have to reboot. I really feel like a reboot is gonna fix this. What if I just run like the normal ISO? Clean. This is my unmodified ISO, right? This is the one I copied to patch. Oh, that's fine. Okay, no, that is me. It is me. We don't have this weird black screen issue. Huh. So how did I just break the depth buffer? What did I do that... How did I do that? Sometimes you introduce changes so bizarre to your code that it's hard to even grapple with what's going on. So where have I written code? What have I changed that would ever cause this to happen? Okay, so what I've got to do, I've got to rebuild this patch. I've got to rebundle this into a disk image. I've got to rerun it. And then, actually I should rerun it with a debugger. Put a breakpoint on my little thing and see what the hell's going on here. Because you can immediately see, like, this is meant to be a white background, so there's obviously some kind of depth buffer issue when it's trying to clear the screen, right? I'm guessing the things that are meant to clear the screen are being discarded. So instantly, like, this worked yesterday, and that's really frustrating. What did I change? I made a small change, right? I don't think I changed anything just then. I was just trying to demonstrate it. Let's reset. We're going to put a breakpoint here. I love watching this get loaded in. That's really cool to me. And so we hit this and we break. Okay? So what do? We load an address. We put that into T0. So T0 is now... it is now the thing that we're going to use to store the state of if this is run. This is this magic address. And we haven't run this already, so we're going to continue to do our thing. We're going to store... So I'm using a double word here on the stack because I thought I had to, but actually I can change this to a single word. That's good. We load chest table stuff. We jump into our EX or shift function, which if we see in T7 now, we should have a random looking number, which is 0, which is kind of weird. You would expect there to be something here. That's okay. T6 has something, but T7 doesn't. This is actually, I think, where we store our state. So we do some stuff with it, we write it to memory, and then we do it all again. T7. Okay, let's step into this function. Where are we? What are we doing? What's going on here? So we load into T7 an address, right? And that comes out as 0. That doesn't seem right to me. And now we just skip over it every time. So how in this little block have we broken the depth buffer? What are we writing? Let's do my favorite trick. Let's do my favorite trick and make this 550. Let's write less data. This was always a good way to start. Maybe we're just overrunning a buffer a little bit and changing some game flag. Nope. Oh yeah, and that actually doesn't make sense because if I get rid of the store command... Oh wait, hold on, I didn't rebuild that, did I? That's okay. If this is a better way to test this, right? Still do all the work, but just stop rebuilding. So if I don't store anything, we still have a broken Z buffer. So one of these addresses... Am I writing my EXOR state into the wrong place? I don't think so. I'm using the LA mnemonic now rather than LI, which was a thing I had to do with yesterday. That was the other small change I made. LA versus LI, important little semantic difference if you're writing MIPS3 assembly. Huh. So we're not actually writing anything here, right? Except here. So what if I do this? What if I do this? What if I... Well, actually, what makes me nervous is the fact that we can clearly see that this label should point to data, but when we try and load it, there was no data. So that's a good place to start. Let's debug. Let's add our breakpoint. And when we run this, something is gonna go wrong. Okay, we step into this. T7. T7 is 0. T7 is not 0. T7 is not 0. Do I need to 0 T7 before I do this? Surely not. Surely not. T7 now has this very random looking number, and when we load we get 0. Okay, so that's a problem. Why are we emitting the wrong code here, right? We're trying to build this label, and that should be okay, but I think we're jumping here. I think we should be jumping here, right? Because then we'll set the whole number. I think that's what we're doing. I think that's what we're doing wrong. So for some reason, and it's probably to do with, so 1, 2, 3, 4, 5, 6, 7, 8, this alignment does not seem to be operating correctly. Now, is there some way that we can tell GNU AS align directive? And I guess this is actually what this warning's about, right? If I make this binary, address of text segment isn't a multiple of the maximum page size. I'm guessing it's to do with this. So probably what I need to say is, and this is awkward. So I went into my make file, right? And I broke all of my other patches to fix this one. But basically, if I change this back to FF1000, we get a little problem. Patch, remove it, and then make it again. We get rid of all our warnings, right? The problem with this is if we go obj dump no, if we go readelf, actually, I think that might be from a different version of this. Hold on, patch. Yeah, so this is okay. But look, the entry point for this now is FF018. And if we readelf, we can see that, where is it? ABI flags? Like, we get this ABI flags section, which is at the address we want it to be, and then the actual text section starts at this weird offset that we don't want. We don't want this. So this isn't where this actually will get loaded. So, I mean, and I guess I could change it, but it would be nice if MIPS ABI flags. There's got to be a way to omit this. There's got to be a way to skip ABI flags. Like, that would fix my problem, right? That would make this less weird. What is it? MIPS.ABI flags. And don't Google it. Here we go. Interesting. Elfloader can't help plugins with these sections. What do they do? Linker. Okay, a linker flag that says to get rid of that section. So that's pretty good. So man ld. If we look at the ld manual, is there a command line argument that will do this for us? Discard. Print map discarded. Strip discarded. Orphan handling, discard section. Discard locals. Retrain symbols file. Print map. Section. Remove section ld command line discard. What is discard? Out format, relax. I don't know what discard is. Linker file discard. What is this? What is this? What does this do? So a special output section named discard. Any input sections which are assigned to an output section. So output section. Output section. Split by relook. Enable linker version. It would be good if non-contiguous regions. Orphan handling. Orphan is a section not specifically mentioned. That is okay. That is okay. Do I need to just write a linker file? Maybe I need to write a linker file. That's annoying. A linker script, sorry. So let's do it. Let's do it. Linker script. Okay, so sections. I have never written a linker script before, so we're making this up as we go along. But this should be okay. So .text, we want to say, yeah, this is cool. Every .text can map to a .text. And same with, I mean, like, .data actually doesn't matter, we ignore it. So actually, yeah, we could just say this, and then we can say discard. Let's just try this. Let's try the most basic linker script I can imagine. So we're using the linker. Oh yeah, and it has a fixed offset. Output A, input output section. It would also be good to set the output here. Let's see if we can do this. Linker script. If linker is invoked at least one object file, you can say other forms, binary input files, LR, script command language, no binary files, blah 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 blah. Bobius, you're back. You didn't miss much. I am diving into the world of linker scripts because I want to discard a section from the final output. Okay, linker script. Where's the script? Script this way. The T option to replace the default linker script entirely. Oh, okay, so what if we, dash T? Hold on, what's dash T? Match case. Script file. Okay, here we go. LD's default linker script. So let's try this. So after before we do this, let's try it here. Let's try it here. So let's say dash T patch rando LD. Let's see what happens when we build this. We're gonna just build the elf. We're gonna remove the elf and we're gonna build the elf. Okay, here we go. Syntax error on line 3. Patch rando LD. Okay, line 3. So straight off the bat, this is not the syntax. And this is okay. We're making this up as we go along. So sections LD script example. Bobius says we're getting into the black magic, and this could not be this could not be more true. I have no idea how this stuff works. So maybe this space is important, and also let's see if we can force this to be at dot equals ff1000. Let's see if that works. Everything else I do not give a shit about, like because of the horrible things I'm doing to this elf. Doesn't actually matter. Seems like linker scripts are just really poorly explained. This is the joy of diving into old technology. Okay, syntax error, line 4. What's the error? I don't know. Thanks linker script. Wait, where'd it go? Did I lose my... Where'd it go? Where'd my F go? Oh, where did my T go? Sorry. Okay, so rando LD. Line 4. Syntax error. This looks like I've done the same thing here, right? So maybe... Oh, so there needs to be a semicolon here. But there's no semicolon here? Let's find out. Okay, that worked. Crazily, that worked. And so does this still work? Obj? It does. This is a really silly way of dumping the object, but that's okay. We're gonna read elf, and we're gonna read elf patch rando.elf. I'm gonna pipe it into less because I like less. And now the text is here. We still have a MIPS API flags for some reason, which is kind of annoying, but our text segment is now correctly aligned. So that's okay. That's okay. Let's try... Let's try repatching our ISO and running. Because I think I was doing a misaligned branch and that was actually the problem. Or at the very least, my code was misaligned, so my branches were misbehaving. That feels like a very hand-wavy version of working out what was going on. So let's find out. And we know straight away if this is going to work because of the background color. So here, because this should be a white background and it isn't, I'm pretty confident that the depth test is still failing. Linker scripts and magic. You've looked into them thanks to OS kernel dev. I would love to do a little bit of OS kernel dev. I think that would pop off, you know, in the views and stuff. That would be fun. I'm just curious in it. Like, I've learned a lot about the ELF file format here, so it would be kind of fun to actually put that to use. Okay, what is going on? So this was fun, right? Because this was meant to just be me demonstrating what's been going on, and instead it's turned into insanity, and instantly things are on fire and breaking. But I guess this is the life, right? So this built everything. Yep, cool. So let's repatch and rerun and see if we can get this working. See if this is gonna play nice. Nope. So the problem isn't writing memory, and that's good in a way because we can actually cut out the write, and it's fine. So are we overwriting part of memory that is bad, right? That's a good question. Have we somehow overridden something that we should not? Are we somehow jumping somewhere that we should not? Let's go back to this, to running this. And it's got to be the EX or shift function, right? That has to be where it's going on. If this doesn't, if we can't see anything obvious here, I'm going to try removing the call to that function. Function in inverted commas. You can manually discard sections. Yeah, that is my next step, but it does actually look like it is... The problem isn't that the section's there, the problem is that it was coming first. Whatever I've done with that linker script is putting the text section first, so that's fine by me. That's fine by me. Let's step through my code. I wish I could make this bigger, but sadly I can't. So, when we jump into this function, let's step into it, and we jump here. This is the start of the function, so we're actually, actually wait, this is a delay slot issue, isn't it? Is it? This comes immediately after... Why does this come immediately after a branch? Nope. Do all of my branches... Let's just make sure all of our branches have nice knobs after them. Also, that looks like a problem, right? Because this stack manipulation is actually in the delay slot for this branch, so that's kind of bad. So maybe that was the problem all along. If you don't know about MIPS, oops, I didn't actually repackage. When you have a branch, the instruction after the branch is always executed. Right, and that's actually a really good thing. That's really what you want, because it means the processor can be very, very efficient, right? It can always, it doesn't know if it's going to branch or not. That wasn't the problem, but that was good to work out. Let's put a breakpoint again. And at the very least, we should get some more clarity here, right? We should be able to see with a bit more clarity what is going on. We're going to reset the console again, the virtual console, and we're hopefully going to break at my wonderful bit of code. Now, there's not... I don't know why there's two knobs, right? There shouldn't be two knobs here. It feels like sometimes the assembler is inserting knobs. I want to be explicit about knobs, you know? I should change this stack manipulation to only do a word, but that's okay, because we're writing 0. That's fine, that's fine. This is all good. Now we jump into this function, okay? So we're still jumping to the wrong spot. We're still jumping to the wrong spot. Where do we actually jump to? We jump to 8C. So we really should be jumping to 8.8. This is the start of the function, and it's still... I don't know what this is. So let's step through this for a bit and see where we end up, because we're almost certainly doing something naughty here. So this is where we loop, right? And we loop quite a few times. So what about here? What about when we fall through out of the loop? Okay. So we load, we set this address. That's good. That's good. That's what we want. And that should be in T0. Yeah, this is our address. This is where we store our state, part of the BIOS. The game shouldn't care about this random BIOS value. We store... Yep, so that's where we do the store. That's fine. Now, we load this from the stack. We always branch here. USP. And that's okay, because we're always going to add to the stack as well. We can do that after the branch slot. That's good. That's good. And it looks like we skip over this, which is probably actually quite important. And then we're going to jump back to our... So it looks like our jumps are just off by 4. Looks like our jumps are off by 4. Why would that happen? How would we end up with jumps off by 4? Also, why is this preceded by a branch? Was stuff getting moved around? Is that does AS potentially do some optimization? Hold on, I'm gonna fix this real quick, right? Because we only need to store a word and load a word, but it looks like these got swapped around. And that's actually cool, right? Let's do that explicitly because it makes sense. We can always restore the stack in the branch delay slot for this branch, right? This branch is always taken, so this delay slot, like there's really nothing to even consider here. But I suspect putting this here is the problem. And maybe I should move this kind of like data-y stuff to after this function. Maybe that would be better. Let's try building it again. Let's try building it again. This is what you can do. Just rebuild and see what happens. Okay, so if this happens again, the next thing I'm going to do is try just not calling EX or shift. And just verify that this is in fact the problem. So let's, instead of this, we're just going to say li t7, and we're going to do 5.3. Right? This is the test item that we used last time. Okay, so does the Z buffer still break? Yes. That's kind of good, right? That's kind of refreshing. We're not doing much stuff, but we're still breaking the Z buffer. This is so... I really wanted a good productive stream today because this worked yesterday. Like, I swear, I did this yesterday and it just ran and worked and there was nothing to consider. And today, it has decided to break. Okay, so, nop. That is all good. We do this stuff. We write all of our fixed numbers. And yep, cool. So let's go to where we hold on, sorry, not the delay slot, the one after that. I don't know why there's 2 nops here, that's okay. We look at this load upper immediate. This is where we store the flag that we have run this code so we don't run it again. Then we jump, we always jump here. So what's this? What's going on here? And we're still jumping one address, or like one instruction too far. We're skipping over this call. And this must be the call that does the Z buffer stuff, right? We're jumping over part of the main loop. This must be an important part of the rendering code. Or maybe not even like the thing that clears the buffer, or I don't know. It might be the thing that clears the screen. I don't know. It's some buffer manipulation, right? Why are we jumping too far? Let's get rid of this stuff that is actually unused, right? These are just some magic numbers that I was going to play with, but we don't really need them. So if I get rid of this, is this going to run? And I bet this works now. I bet it was this weird padding I put in. Yeah, okay, so it was this. I don't really understand how, but having a bit of padding here has gotten everything out of whack, out of alignment. So that's okay. We can deal with this. We can deal with this. This is good news because we can go back in here. We can rebuild our patch. We can rebuild a binary. See, I wanted to have constants in Okay, actually, I know how I can deal with this. I know how I can deal with this. So, let's demonstrate what I've done and that it actually works. That only took 30 minutes of a stream to get back here. That's fine. I think this is just my computer having a fit. Maybe? Maybe not. Maybe it is actually a problem. Okay, can I get rid of the debugger annoyingly? That menu takes a very long time to load. Okay, maybe this isn't just my computer. DMA does not terminate. That's not good. We don't want DMAs to not terminate. We want DMAs to terminate. Not terminated DMA means that the renderer is shitting the bed. So that, again, it feels like maybe something we're doing in this code here. So that's good though, right? We can, again, look at this with the debugger. We can jump to my code and we can see where this is going wrong. I wish I could show a better example of the fun part of this, but also, you know, this stuff is just extremely tedious. There's not necessarily a fun part to it. It's just a lot of stuff. So we can see now in T7 we do get a random number, which is great. I don't know why we have 2 nops here still, but that's okay. And then we're going to mask it down into just a byte. We're going to store it. That's all good. T0 has an offset into the chess table, which is great. And then we're gonna work our way up. So now let's look at the bit when we fall through the loop, when we're done. Or we set this magical address, which is correct, and then we jump down to this function, which looks correct. That looks good. And then we jump back to where we were. Cool. We're fine. We're all happy. We're good. That looks all correct. What do we do here? That also looks correct. So both of these look good. Both of these things look wonderful. And yet, enough data does not reach VIF1. SEGS exec store image. Enough data does not reach VIF1. What does this mean? That's really weird. DMA channel 2 does not terminate. Sync path. So we're waiting for something forever, basically, right? We're waiting on a DMA to complete or some kind of draw to complete, and it never does. So we get stuck there spinning. Let's do this again. Let's do this again. Add IU T7 0. Let's add 5.2 to it this time and see if we can hone in on what part of this code is actually causing a problem. Right? And it feels like we're honing in. It feels like we're honing in. So we still have this weird slowdown there. Let's do the other thing that I like to test and just get rid of the part where we actually write anything at all. And you know, maybe this is to do with the new linker script. Maybe there is actually a problem with that, but the code looks correct. It looks like it can run just fine. Oops. Where is this going? What is going on? Weird. And this is going to hang again because the DMA isn't completing. Okay. All right. So Has run, restore. This just all looks okay. I'm just gonna do this. I'm just gonna do this. Like, we're not writing anything anymore. How have I broken this so badly? How have I broken this so badly? Because again, yesterday this worked, and that's very concerning. Has run, so that this is fine. This is fine. Everything looks fine. We're loading in the address we want to. We're jumping to where we want to. This is really strange. And this is why I haven't, like, people were like, oh, why didn't you stream the building the binary loader stuff, like the part that actually loads this code? The reason is this. The other thing that's worth trying, okay, because the other thing that's really probably worth trying is to go to the software renderer and just make sure that this isn't a weird stateful hardware renderer thing, right? I don't know what this is going to do to my CPU. And now we're back at this. What the hell? How did I get back here? What's going on? Oh, wait, hold on. Whoa. I think what I meant to do was the other version of this, where I wanted some nops after here, right? Let's try doing it this way. But it really does feel like AS is messing with some of my code here, right? That's the kind of upsetting thing, I think. Because we still have this weird situation where we have too many nops after things, and that's not great. So we can step into this, and this is good now, right? This loads the correct thing. This loads our state 1, 2, 3, 4. This is what we've hard-coded it to. But if I step over all of this, stored. So those nops disappeared, which I guess makes sense, right? Why would a compiler care about a bunch of nops? Maybe I need to put an instruction in that does something with no effect, just to see. So when do we hit this? We hit this, right? We hit this, we step into it, we jump into this function, everything is cool and good. Step out. And so that should be fine. And then we just jump back into our code right after cool, which again is fine. And then all these functions run. So how? Well, unless we do something weird here, right? But we don't. And again, when we jump out, we jump into here, we still call this function, and then we go back to where we were. So this all looks very, very good. This all looks perfect. And the depth buffer is okay now. Something very strange is going on here. I don't think I can fast forward. Okay. But then we still have this DMA problem. And of course we do, right? Because if it's a DMA issue, it's not as simple as just, this is really frustrating, because this worked yesterday, right? This is the problem. This is the problem. When things non-deterministically work. And the problem really doesn't seem to be anything. I'm going to get rid of every store word that I have here, right? I'm going to get rid of them all. I'm going to get rid of every single... Oh, but this is important. What if I do... If it's less than... What if I do greater than... Can I do... Is it GT... Is it BGEZ for greater than equal to 0? So just skip running the code entirely. What happens then? What happens then? I'm getting desperate. I'm grasping at straws, right? But we've just got to keep trying stuff, because this is going to work and it's going to be really awesome. And it's just a matter of working out the right combination of things. Okay, so when we don't run our code, the problem doesn't happen. We don't do anything. We don't randomize anything, but that's okay. When we don't run our code, the problem doesn't happen. Let's swap back to Vulkan, because we want to do stuff fast. Okay, so that's good, right? That's really good. We can put our code in memory, and as long as we don't run it, no dramas. And this looks okay as well, right? We're loading a word, we're storing a word, we didn't do anything weird here. let's go back to this. Let's go back to doing it like this, just in case. Just in case there's something strange going on here, right? Just in case. Let's go back to doing the stack manipulation the sensible way. Okay, so. Because I didn't really give that much attention, actually. It was that stack manipulation function. So did I actually run code here? Am I actually doing stuff? Let's find out. Let's go open a chest. See what's in it. I love it when it takes me 47 minutes to demonstrate the thing that I worked on off camera, but that's okay. You've got to grapple with the realities of this being a slow, frustrating process sometimes. I wish it was fast and sexy, but this is the pain of modding old weird games, doing jank unsupported weird binary hacking. I kind of got this funny idea that maybe I should write my own elf linker. Or object linker, I guess, not necessarily an elf. I don't know what's more accurate. But because of the way I'm building these patches, if I could relink them using Go code, yeah, okay, so that's randomized. That's not what you normally get there. If I could relink these using Go code, in Go, I could put them at various memory addresses. I could do that allocation when I patch the binary. And then I could actually write these in C. So that's kind of my long-term thought for where I could go with this. Oh, he hasn't despawned. This guy is going to give me grief. Okay, that was kind of perfect. I think that despawned right as I went past him. What's in this chest? It's going to be random. Well, it's going to be random within using a fixed seed anyway. Nice. So we have randomized chests, and that's kind of awesome. And it's runtime randomized when the game boots up. So that's really, really fun. That's a lot better than what I was doing before. As long as I can find a sufficient source of randomness in the game on boot, which I will be able to do. There's a bunch of memory addresses that are a bit kooky. I'll be able to get something from memory that is effectively a pseudo-random. That's an effective way to see to PRNG. That'll be fun. Cool. So that's what I did off camera. Now let's start doing something new. That's fun. That's really fun. It would be good to understand why that all happened like that, but we'll have to think about that later. I'm gonna swap. I'm gonna put this up here above my little fixed seed. Also, this should probably have a nop after it, right? Maybe that was the problem, actually. Maybe the lack of nop there was the problem, because jumps have a delay slot as well. So if I rebuild this and rerun this, does it break the game? This is the ultimate question. Unfortunately, testing this is very, very slow. I should run without the debugger. That would be better. That would be faster. Thankfully, I can fast forward through this. Okay, this looks good. Okay, so I think this is a better way to start building out weird state and stuff. Cool. This is nice. Let me actually commit this. What branch am I on? Excellent. It's a branch called rando. Rando LD. I'm writing bad commit messages because this whole project has turned into a bit of a mess. That's okay. That's okay. Okay, so let's talk about the things I actually want to do this stream. Fill and swap. So my basic approach to doing this is going to be that the default loot table for this game is a bit crap. It's not really fun to randomize, I think, because there's a lot of really garbage items like gummy blocks that I don't think would be really part of the gameplay. Now, having some trash in chests is fine, but I think I can make more interesting trash. So anyway, or items or something. I don't know. So my thought is I'm going to completely refill the item table and then swap them around. The swap part is going to be simple, and I guess the way that the randomizer on PC works is it just swaps all of the chests using some logic anyway. It finds pairs that are compatible and it swaps them. But I want to try and fill the table with something else first. And that means that we're going to have to do 33 chests with dogs. We're going to have to do 4 chests with emblem pieces. We're going to have to do maybe a couple of other special items first, and then swap them around from there. So that's my basic idea for how to build this up. We'll have a big list of things. You know, this is our chest table, right? A whole bunch of entries. The first n entries will be dogs. The next few will be emblem pieces, right? Other special items. And then everything else will be random stuff. Cool. And then we're going to have a step where we go through and we shuffle these around. I'm not going to have any logic right now, so the seeds will probably not be beatable. We could put, for example, an emblem piece after the emblem piece door. This is kind of the main blocker in the game, right? Finding 4 emblem pieces to beat Hollow Bastion. But we're just going to roll with that for now and accept that logic is going to be hard to do in assembly. This is going to be like a proof of concept that may not always generate beatable seeds, and if it's good and worth doing, then I might explore writing a linker in Go and using that to write better patches in C that can play nicer together. That would be fun. They will have to fit into 4 kilobytes still, so maybe assembly still has merits. What are we at? Hold on. Okay, we're at 184 bytes out of 4 kilobytes, so I think we're actually doing fine. I think we're fine. So now instead of this loop, the first thing we probably want to do is repopulate the loot table. Let's call it the chest table. Okay. Let's just do it like this for now. So we're gonna load T0 is gonna have our chest table, and are we gonna do an offset and a register, or are we gonna count up until the end? I think we're gonna do it like this. We're gonna do it like this. Except this is gonna be T0 and T1. The first thing we're gonna do are 33 dog chests. Just put some dogs in a box. So we'll say dog loop head. We need to put the magic number. We're gonna add IU T2. We're gonna put the number 33 in here. We're gonna do this 33 times, and every time we're gonna advance T0. Okay, so dog loop head, and this is gonna be very similar. It's gonna be very, very similar. Now let me just double check. Rewards dog. Getug. So I think these need to have different numbers after them. I'm not 100% sure. We'll work it out pretty quickly. We've got a, so what is it? It's the lower 4 bits have to be 4. So let's add IU. Let's make T3 the thing that we're building the value in. We're going to load 4. We're going to shift left T3. No, wait, hold on. We're going to, I think we can mov. We're going to move T3 into T2. I think that's how we do that. And then we're going to shift. Wait, we're going to move to T2 into T3. I think the thing on the left-hand side. I'm just going to write an add. We're going to add T2 to 0 and store the result in T3. Because I know the order of registers in add. I don't know for mov. Mov isn't a real instruction, MIPS. We're going to shift this left by 4. And then we're gonna OR I T3 with the number 4. So this is making it a chest that gives us some dogs as a reward. This is wonderful. Now that we have this value, we can store it at, we're gonna store whatever we have in T3 at T0 with no offset. Now we're gonna add IU, we're gonna add 2 to T0. So we're going to have a couple of very similar loops, and then we're going to also sub IU from T2. We're going to subtract 1. Now we're going to branch if, I think branch equal to 0. Let me check my instruction guide. BL, I guess equal to 0, branch not equal. Let's branch on equal. Okay, well, we could actually do that. Branch on equal if t2 is equal to 0. That's probably better than doing a less than check. It makes a little bit more sense. So, except we want to branch if it's greater than. Hold on. Dog loop hat. Okay, so if we still have dogs left, branch up here. This needs to be 34. Is there a sub I that isn't sub IU? Sub I? Sub U. Oh, there isn't a sub I. I guess we can add -1 though, right? Add I -1. Okay, let's do that instead. That's silly. Add I t2 -1, subtract it, but subtract it, and so as long as it's greater than or equal to 0, so we'll do this 33 times. Yeah, cool, okay, because we want, as long as it's greater than 0. Okay, here we go, we've got it, this is the logic. I hope that's enough dogs. Cool, so then once we're done with dogs, we need an op here as well. And actually, we can put this in the delay slot, and this is a bit more efficient, right? Because we branch back to this loop, but every time we do this, we're gonna add this anyway. So instead of, like, this is the thing that is related to the loop condition, but regardless of whether we branch or not, we're always gonna advance this, so this is a good opportunity to put something in a delay slot. Okay, so now we're gonna have, I guess we could do, now, I can't remember the item. There's a big list somewhere, hold on. There's a repo somewhere that has a list of all the item names. I think it's in this repo. 1fm, rando files, no, scripts. Where is it? There's a file somewhere that has, does this actually work on Linux now? That's kind of cool. Maybe I don't need to do my silly thing anymore. Rando sum logic. I swear this had a file in it that had the names of all the items. Let me go back in time. Not that far back in time, hold on, 24, 24, 24, let's go back to 2022, I guess. Browse files, 1fm mods, rando files, yeah, this, right? Where did this go? Emblem piece. So BC, BD, BE, and BF. Okay. So, this isn't going to be a loop, right? We're just going to do this the old-fashioned way. We're going to load a magic number. That magic number, actually we can add IU it. It doesn't even need to be fancy. We're going to load into T2. Wait, hold on. Let's li. Let's just let the assembler work out the best way to do this. So we're going to put the magic number. It's going to be BC0. This is the magic number that loads. This is the magic number that tells an entry, like when you open a chest that has this value in the chest table, it's going to give you item BC. Okay, and then we're going to store word. We're going to store whatever's in T2, and we're going to store it at the no offset from T0. But then we can do a couple of cool things, right? We can probably add IU. We can probably just add hex 10. right? Because it's BC, BD, BE, BF, but it's not, like, it's in the second bit. It gets shifted over 4 bits. So we can add 1 left shifted by 4 bits. That's the same thing. Except now we can set the... also, there should be a half, shouldn't it? Oops. Well, that probably messes up a few chests. We only want to store a half word, right? We're only storing 2 bytes. Do I have a store half instruction? Of course, I need to look at the big list. LHS, store H, store half word. Cool. Least significant 16 bits. Perfect. That's exactly what I want. Glad I caught that. That was gonna cause problems later. So now we can just do this a few times. And I'm gonna write this out because it just makes more sense. So BC 1, 2, 3. I'm gonna do this a 4th time at offset 6. Awesome. So we've written 4 sequential entries. Now, I guess the other thing is, I don't know if all of these entries in the table actually map to chests in the game. So that's kind of a problem potentially, but we'll work that out. We'll work that out. I don't know how we'll work that out, but we will work that out. For now, I think this is an okay way to go, right? Fill and swap. I think that's pretty good. I've got a funny lump on my arm. I think it's a mosquito bite. That's okay. So are there any other special items that we want to place? That's okay. And so now all we need to do is add 2, 4, 6. All we want to do now is add 8 to T0. So add IU. Does add IU take 2 things? I think it does. RSRT, yeah. So sorry, all of my add IUs are a bit wrong. T2, this is also going to do that. Add IU T0. Add IU T2, T2. Has to take a thing and a destination. So then we're going to increment T0 by 8. And the next thing we write at the 0th offset of T0 is going to go into the slots after these items. Cool. So now random stuff. Now this is where we do this bit, right? But and also this is now in T1. So everything that's T1 here is going to become T2. I should probably do this with a find and replace because it's very imprecise, but I want to also see that. Cool. And this is good because it slots really nicely into what came before, right? So now we've placed dogs, we've placed emblem pieces. It would be good to place a chest that gives you the high jump ability. That would probably be worth doing as well. But we can get there later. So high jump and glide, I guess, would be important. Let's see if we can compile this now. No, BGTZ. BGTZ. I forgot to put a comma in. That's okay. Beautiful. Let's repatch and rerun and see what happens, because I don't know where these chests are that I've just populated with dogs. I think earlier game chests tend to come earlier. Also, get this debugger out of here. Oh, I thought it crashed, but I was just paused. Earlier game chests tend to come earlier, so it would be interesting to see if, when we open chests in Travis Town, that they're all dogs. That would be useful. That would confirm something. Or they're just going to be random garbage. Let me get that mouse cursor out of here. We don't want to see a mouse cursor. All right. So this chest here, and I'm getting, well, I was about to say I'm getting better at this fight, but I'm missing everything. Oh gosh. Oh my gosh. I've had to do this so many times to test this one chest, and I'm still flopping it. Oh, I was hoping to grab him off of the spawn. That's okay. It's just lining up these jump shots is always a bit of a mess. Now I think I can get in without spawning more guys. Okay, here we go. So, are we going to see dogs in this chest, or are we going to see some random garbage? Froststone. Nice. That's not what I want. See, that's the other thing. There's a lot of garbage synth items in this game that, again, not sure what to do about putting them in chests, because the current thing will just put them in chests. So maybe there needs to be a little bit more logic rather than just a binary and. Maybe we need 2 categories. Maybe we need like good items that are things you would actually want, and then stuff that could be junk or could be useful. I think that's a decent delineation. Or like, rather than just full, oh no. Oh no. It's gonna take a long time for this to despawn so I can get, oh no. Oh no. This is the only trouble with this game and not opening chests in combat is it's really annoying to test this stuff out. It would be great to hack the game to let me not do this. Okay. That's very silly, but we'll survive. This game has absolutely terrible platforming, but I still love it. Okay, here we go, here we go. What do we see in here? Is it dogs? A dazzling stone. Is it possible? Because I imagine those are sequential items, right? Frost. Oops. Dazzling stone. Interesting. The fact that these 2 items come so close together makes me feel a little suspicious, right? Have I broken something with how these get randomly generated? Or was that just a fluke? Was that just a fluke? What do we actually store here? We store T2. What's T2? T2 is the thing we bitmask, so that's okay. Do I need to clear T2 before I do this? No, this clears T2. We store T2, T0, we add... I guess that could just be random. Let's change our random seed and redo that and see if that looks the same, because that'll tell us if we're not actually doing something random. It isn't actually, because this is a low number, that also makes me suspicious that that should have been a dog, but it's not, right? Like maybe instead of a dog, we are just writing the first kind of, you know, n items, right? The first 33, I guess, which is, in hex, 33 is 33, so that's 16, so 20, so it would be up to here, right? Up to dark ring. That would be worth checking. That would be worth checking. So if I open this again and it's the same item, then that's a good sign. And then I can probably go to one of my other saves and see if it's consistent, right? See if I still get one of these early items or if I get other random garbage. This is a good way to test. Unfortunately slow, but it's still a good way to test. Also, I can unmute the music. I did that for the BRB screen when I was testing, but so unfortunately you guys are missing out on the bangers. Okay. Man, who would have thought this was the longest part of doing weird binary injection, just fighting dudes. The air combos are really just not worth it, but I just want the style points. I know it's technically faster, so I just want to do it like that. Thought I had a little leeway for this. Okay, it's going to be quicker to fight these guys than to try and despawn them. Actually, no, I can just cycle the room, can't I? We're good, we're good. We've got them, we got them. Okay, and they'll be fine. There'll be no more enemies here. I can open my chest in peace. So what was it? It was a frost stone last time. Really random item. What do we get now? Angel Bangle. Okay, that sounds good actually. For one thing, that's like a weirdly, really random item. So where's Angel Bangle? 28. That's not so high in the table that I'm not unconcerned. Right? I want to check this other one as well. But it means that it is not the same thing as last time, so it can't be the dog logic, which is good. Also, I can actually work out, I think one of these chests maybe is in my list of known addresses. Despawning these guys is really annoying. And now he's going to respawn here, maybe. Or he's going to re-aggro on me here. Okay, there we go. I just want to really make sure it despawns. I think if you go into first person, it changes, like, because the camera's further away. The despawn's based on camera, so it's like some weird manipulation thing. Okay, fish. That is a later item, I think. Yeah. Okay, that's good. So this is random. This is random. Let's just check my other spot as well. See what we get. I would love to know where these first 33 chests actually are, because maybe writing the first 33 chests is not the way to go. Maybe they don't actually map to anything. This is a bad save point for opening a chest. Hold on, that's not the one I wanted. But yeah, Bobbius, why are you looking at, sorry, this is like an hour-old thought. Why are you looking at garbage collection? What has drawn you to garbage collection on this fine late winter, well, I guess it's not late winter for you, but you know, late summer period. Oh, the worst room in the entire game. Lisps tend to have a GC. Yeah, I've heard of Lisps using Boehm GC. There were... did Lisps, like, invent garbage collection? I actually didn't know that. I just assumed... Like, I assumed they were an early pioneer. They did a lot of work in it. I didn't realize they invented it. That's really cool. I guess it makes sense, right? Because before Lisp, like, what were you doing with a garbage collector? Because, I mean, you know, like, Lisp goes back to the late 50s even, you know, it's pretty early stuff. That's, the more I think about it, the less surprising it is, but I definitely didn't know it. That's a cool bit of trivia. Okay. This is not too hard of a jump. This is a very approachable jump. It's a very jumpable jump. It's just, this game has really jank platforming. I don't think you're meant to actually be able to do this. I don't think the game devs intended for this to be a jump you could make, but that's okay. We're gonna get this chest. And again, I actually know the memory address of this chest in particular. Thank you. There we go. I still almost missed that. Okay, that's that is something. I've never seen that one before. So a couple of these items, right? And this is the problem with just doing this randomly, right? So what do we get when we EXOR shift and then mask by the lower one byte, right? We get a random number between 0 and 125. Turns out some of these low index items, or high index items, I mean, all of these actually have an entry, but like some of these items, right? They're not real things that we want to use. They're not real things we can equip. Unused. Nowhere. So that was item 88, I guess, right? And I'm guessing that's, you know, like a party member item thing. But some of these we really don't want to get. We don't ever want these to exist. So, oh yeah, the books are important. These need to... So this is more stuff that we probably actually want to make sure we give out at the start of our loop. These are probably fine. And the other thing about this is that it actually tells us where they come from. So the way the actual like PC rando works is it has this metadata associated with items and chests, and it somehow can correlate the two and work out what should be gettable, which is cool. So it's like, oh, to get this thing, you have to have these things. But I don't really know... Or is this? Yeah. Anyway. It's useful. It's good to know. I think they have a chest one as well, right? A chest and a rewards one. So this is actually the index of every chest in the game, which is cool. A constraint system. Exactly. And actually, we can see that the chests that are actually used, like there's quite a few chests that are just completely unused. This is a bit of a sparse table. So, maybe this is something we need to deal with. Because if we just try and put 33 things in, well, the first n are just never going to be reachable. I'm going to run to the bathroom while I ponder this for a second. Okay, I've got an idea. Bobius says Pokemon randomizers have to do with constraints. There are so many permutations which can lock progress. We're going to have a similar problem here, but I think Kingdom Hearts is a little bit more simple when it comes to these limitations. So we want to only write things into the entries that are well defined and that map somewhere. Are these the only chests in the game? Are these question marks just unused, or are they just unknown to... Okay, hold on. What's the latest... I want the history of this file. Can I get the history of this file? Okay. So some of these newer changes actually just deleted it. They've got a new system. That's okay. That's okay. Let's look at this file. Okay. As it was however long ago. Chests, sorry. So what would be really nice is if we could only write things here that correspond to actual spots, actual slots. And how do we represent that? Because it would be really good. I mean, first off, anything Destiny Islands we probably actually just don't want to use, right? But I don't think... There's only one chest, so we can just skip chest 0 entirely. That's nice. So I could store every index that's valid, right? I could make a big list. I could say, valid chests. And I can say byte. I could start at, 14, 15, 16, ... right? Except these numbers get bigger than a byte can hold. I would actually need 2 bytes for every chest. Okay? So that's going to take up a lot of space. I mean, there's, maybe 100, let's say maybe 200 bytes just to represent that, maybe more. And that's bigger than my code is currently. Remember, I'm working within 4 kilobytes. Is there a smaller system that I could use to compress the information about where, where these indices are? So, use a mask. That's interesting. I don't know if, also welcome, Ahelia? Welcome. Mask is interesting. I don't know if mask is the right solution here, because there is a pattern. There is a lot of contiguous stuff. You need 512 bits. What do you mean 512 bits? What would I be representing with those bits? For the whole thing, right? Yeah, okay. That is actually a good point. That's a very good point. That's actually an extremely good point. I was going to suggest a kind of variation on run length encoding where you could start, you could say the first index is 14, and then there's 1, 2, 3, 4, 5, 6, 7, 8, and then, you skip 1, and then there's 1, 2, 3, 4, 5, 6, 7, and then you skip 4, and then there's 1, and then you skip however many this is, and then there's... But that will take up more space than 512 bits. The only thing with that is it's awkward to build, but I guess I can just download this file and parse it and build it like that. So let's do that. Let's download this file and let's write a shitty Python script that's going to turn this into bits. Let's do that. That's a really good idea. That's a really good idea. And actually, I can put this in a constant instead of a label. This can be compiled in as needed rather than living in a memory address. Chest, valid chest bits. Wait, 512 bits. Actually, no, I can't put this in. I do need to put this in an address, right? Or unless I split it into a few bits. Yeah, bitmap makes sense. Bitmap makes sense. Thank you for the suggestion. I was going to do something more complicated, and well, I guess easier to maintain, but still complicated. Let's say chest bits. The only hard thing is I'm going to have to split this into 4 32-bit words, right? 1, 2, 3. 1, 2, 3, 4. 4 bytes. Right? I'm going to have to split it into four parts. Which is okay. That is okay. So let's write a little script. Let's go into patch. Oops. Actually, I'm going to rename this file to have a lowercase c because that's better, as f. For line in f. So for each line in this file, if, let's split it on, I'm guessing, is this a tab? This is a, yeah, I could mask off. So it's a little bit more complicated than essential key. There's a little bit of like interdependency. But yeah, like this could actually become part of the mask. Maybe, yeah, maybe I could use more than 1 bit per chest, right? Maybe I could use 3 or 4 bits per chest. That would potentially be better. That would potentially be much better. So what's a good AS directives words? Is there a way to do data that isn't just GNU, that isn't just bytes? Because just having a big blob of literal data would be kind of useful, right? Word, hword. 32 bits. Word directives, word, okay. So we could do that instead. We could actually do that instead. But then we need to know where it was. But yeah, this is a good idea. This is a good idea. Let's do it with 1 bit for now, but I think it would be worth trying to expand it in the future. So for each line here, okay, for each line here, let's do any lines that are not empty have this question mark? No. Okay, so let's say if, we have to do try catch in Python, don't we? Try line dot index question mark. Do I have to say except D or can I just say except? Except pass. And then the offset, we want to enumerate. There's not a good way to enumerate a file line. Read split n dot enumerate. Is that what I want? I line. Something like this, right? So we have the index, and then we're gonna say, we're gonna have a list of words in the output. It's gonna be like 0, 0, 0, 0, 0. It's gonna be 0 times read lines. But can I enumerate read lines? Does that give back an array or does it give back something weird? We'll find out. We'll find out. So it's gonna be, there's 479 entries in the table, right? 470 lines in the file. What, 1FD? 509 lines in this file. What? Is my chest table too small? Okay, well let's do that for now. 509. And each entry is 1 bit. So the number of bytes is going to be this divided by 8. So the number of words is going to be this divided by 8 bits per byte, 16. So it's going to be this divided by 32, right? Except it's going to be and that'll give me an integer. 5 divided by 10. No. So I need to math.floor it. Oh no, I have to do double slash, right, in Python. That gives me a integer division. Yeah? Yeah, cool. I always forget. I always have to remind myself how Python handles this syntax. All right, we'll find out. We'll find out. So we want to first get the word index, right? Which bit does this word belong to? That's going to be word index equals I divided by 32. Then we need to work out where within that word we are. So that's going to be word bit equals I mod 32. And then we want to say out words. And we want to do the opposite of this, right? So if it doesn't contain this, outwards word index equals outwards word index or word one left shift word bit. Right? So if that bit isn't set, then set it. And then we just want to print for, what do we want to do? For word in out. Print the word as hex. And what is Python print? I think it's LF for, what's the, how do we say no new line? Again, this is one of these really silly little Python things. End equals comma. Right, we're just going to comma separate them, and then we're going to print at the end. Cool. So this should hopefully build it. There will no doubt be something wrong with it, but that's okay. Chests.txt, we're going to put it in our patch folder. We're going to go into our patch folder, Python, what did I call this? Build chest bits. Oh yeah, oops. Build, I always forget that's how this goes. Try this. If this throws an exception, then we're gonna set the bit. I hate that Python does that with index. I really don't enjoy that. Chests.txt, where's chests.txt? Where did it go? We lowercase file names here because this is Linux, yeah, so read lines, so, but I think if I go read.split, then I get an enumerate method, right? No. Oh no, hold on, it's a function, not a thing. I always forget, I've been doing too much Rust. Enumerate. It's a function that takes an iterable. There we go. Okay, so these are the bits. And also I wanna, just for clarity's sake, what do I do here? This. Nice. And then I probably want to say 0x. Okay, so these are my chest bits. Does this make sense? No, it doesn't, because if I look at, oh no, yes it does, because we're least significant bit, it's hard to read them. So, you know, we would expect 1 and then a bunch of zeros. The 14th bit is 1. So where's the 14th bit? This is 4 bits. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so this doesn't quite work. This doesn't quite work. That's not right. That's not good. That's not ideal. Why? Oh, yeah. Why do we have the wrong number? Why isn't this bit set? So let's just say if I greater than 32, break. Let's just do the first word, right? Okay, for some reason that's still 0, 1, 2, 3. Oh yeah, because we still do the 30 second, which is, yeah, okay. So here, so this should just set the lowest word, and it does. Okay. 1 over, yeah. Big Egg, welcome, thank you for stopping by. This is getting nerdy. It's getting technical. So let's just do the dumb thing, right? And do some debug printing. Let's say bit I And this will at least tell us like what bits we're setting. And it's interesting because you would think that 0, 1, 2, 3, 4, 5, 6. Oh wait, hold on. This is right. This is 20 because these are hex numbers. 1, 4 in hex is 20. Okay, well that's good, right? So we can see that in the first, we get 20, 21. Actually, let's print this as hex. That's going to be better. Okay, 20, 21, 22, 23, 24, 25. What's the first one we skip? Actually, wait, no. Where's 1, 4? Oh yeah, 1, 4. Sorry, I'm reading the wrong column. Word equals. I didn't know that. I didn't know that syntax. That's pretty cool. But can I still format as hex? Can I do like word equals :x? Python's pretty clever. Python always has these funny little things. So 14, 15, 16, 17, 18. We expect to not see 1C, and we don't see 1C all the way up to 1F. Nice. Okay, so maybe that's actually just fully correct, and I'm chasing a ghost. So that's nice. Cool, so this is the data we want to have in our binary. Let's try doing that. Let's try doing rando.asm. Let's pretend that doesn't exist, and let's say chest bits. And this is our big dumb list. Not 100% on mixing it. That's homework for the viewer. Mostly when you're dumping a bunch of variables, that makes a lot of sense. Okay, so how do we actually read a bit from this, right? Maybe I want like a function that does, get next chest index, maybe. We'll call it something like this. And we're going to have assumptions. Assume T0 is our chest, is our current place in the chest table. So let's do this. Let's write. It's going to overwrite certain registers. Yeah. Index of the chest. Read a bit. Except it's not this simple because my indexes spill over multiple words. So I need to work out which word we're in as well. So I need to work out the index mod 32. But that's good because index mod 32 it's the remainder divided by 32, which is also just one instruction. I actually think I need to break for lunch. It's cool to see some new faces popping in and giving some guidance here. This is very, very useful. This is a really good way to do it. So basically it's going to go something like this, right? I'm going to quickly hack this out and then not test it. So yeah, we'll say T0 is where we are in the table. How are we using? T1 is where we end, which probably isn't ideal. And then we need to return in a register as well. So we'll probably like return in T5. The fact that I don't want to... Anyway, there's a lot of stuff. These are like really shitty, bad functions that just have certain guarantees about overriding first, which is what real functions do as well in C, right? And cooler preserved versus coolly preserved registers, all that fun stuff. We're just simplifying it all down to its barest element to make function calls simpler and faster, and take up less space because we only have 4 kilobytes. I don't know if I've mentioned that. We only have 4 kilobytes. It's all good. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's 15 times... Okay. Yeah. You're using the I know what I'm doing ABI. Yeah, this is it. I'm using the Tom's Brain ABI. I'm using the read the comment before you call it ABI. Worked really well for PRNG, right? We're just like, okay, we override these registers. That's fine. So let's put it into T7. So we've got our place in the chest table, right? So this is going to be an index. Currently it's the full address. We now want to turn this into an index, and I'll do that conversion in my brain. So T0 is where we are the index that we're dealing with, right? Current place in the chest table. Also, I want to turn this probably into a 0. That's okay. We'll think about that later. So, T0's our current place in the chest table. The next index, so we want to divide this, so we need to work out what word we're in. So we're going to divide, we're going to store the result in. Now there's high and low, right? These are, I closed this for some reason. So let's look at div. Div, divide word. We can probably do it unsigned. Low, high. So how do we deal with low and high? RS divided by RT. Okay, so it takes two things. We're dividing, so we need to load an immediate. We need to add, we're loading an immediate. We're going to load into T7 the magic number 32. Then we're going to divide T0 by T7. Now, how do I deal with low and high, right? How do I actually use these? MF high. This is it. This is it. So we move in and out from these registers with special instructions. MF high, MS low, MF low. Cool. Okay, perfect, perfect. So div, it's div u. That makes more sense. Div u. High and low. What are high and low? The 32-bit quotient, the 32-bit remainder. Treated as unsigned value. So I want what's in low, right? I want what's in low because if we divide quotient remainder, yeah, I want the thing that isn't the remainder. The remainder is going to be the bit. No, it isn't. It isn't. Yeah, no, the remainder is going to be the bit within this. So we're going to move low into. Let's move low into T7. I don't think that was the right thing. MFLO, MFHI, MFLO, and then we're going to MFHI into T6, but we may not actually do that until later. So now that we have this, this is the word. We're going to add IU, we're going to add... No, we need to do a load here. So we're going to load, we're going to load. We're going to add IU, MF low. No, so we're going to add to T7. We're going to add to T7 the address of chest bits. Right? I think that's okay. This might be too big to add as an immediate. That's the only problem here. That's the only problem we might run into here. But let's do this for now. So we're going to add chest bits to T7. So now we have the address of this table. So chest bits is like the address of this, but we're adding an offset into that, so we can just load this word. So let's load word into T7 from T7, right? Dereference T7 into itself. Then we're going to get the high. This is the bit, so we're gonna load into T5, I guess. The number 1. We're going to shift left T5 by T6, and we're going to store the result in T5. And now we have the actual bit itself. So, we've got the mask to actually read the bit. Actually, wait, no, we can do the opposite, right? We can just shift right. We can just shift right. So instead of shifting left and testing the mask, we can actually just shift the other thing right and test if the lowest bit. And I think we can do that with one fewer register, I think. This will work as well. So we can ANDR. I think it's ANDR, right? And it's just AND. Just AND. But I'm pretty sure it's SLLR for shift left register. No? SLL. Where's SLL? SA. What's SA? SA is V. This is the, okay, sorry, SLLV, shift left by a register. We're gonna AND T7 with T5 and store the result in T7. And then, wait, this needs to be in a loop as well, right? So we're gonna do this until we run out of stuff. But this is a bit more tricky than I thought. Let's do the simple thing, right? The simple thing that might fail sometimes. Okay, so, because this is useful to have. We don't want to have to do this loop all the time. We want to be able to jump to this, do it, and then jump back. And actually, the only problem is what we do when we run out. That's the thing. When we run out of chests, where do we jump to? Maybe we just return like a dummy value. Maybe we just return 0 or something, you know, something bad, or -1. We can think about that. So if this is 1, we want to return, well, I guess we just advance. We just return T0. This is hard. So we need to think about how this is used, right? T0, is T0 the thing we're testing, or is T0 the previous one? T0's probably the previous one. So probably the first thing we do is add IU, T0, we add 1 to T0, then we do all this stuff, okay? Then we divide it and whatever. And then we want to branch if it's equal to 0, T7, 0, we want to branch back to next chest index. But we need some special case for the end of the table. Otherwise we're kind of done, right? So we branch back. We keep doing this until we find a valid entry. And then if we have a valid entry, we just jump back to the return address. And we need another not to space that out. And I think that makes sense. I think that works. I think this potentially works. Probably hot garbage, but potentially works. Next chest index. So this looks like real code. I like it. I like writing stuff that looks like real code. The fun thing is, because we're never nesting calls, we can actually jump and link here, right? So, and it's okay that this starts. So this now needs to start at 0, right? And this just gives us back an index. That's the other thing. That's the other thing that's hard. So T0 starts at I guess if we put the, I guess we could also put this check here. So we could say I love writing things that look like real code. Quote me on that. Quote me on that. Mr. Jackhat followed. Thank you very much for the follow. I hope you're enjoying whatever this is. Before we do this, right? Before we do this, we need some kind of terminal condition. We need to say, okay, we're done. And actually, when we run out of spots, we're probably just done. We probably stop caring, right? We probably stop caring. So we can probably just jump to something. So let's say we're gonna load 479. We're gonna subtract into T7. We're gonna subtract T7 minus T0, and if this is less than or equal to 0, T7, we're gonna jump to out of table, and out of table is gonna be down here with skip out. This isn't going to be a long-term solution, but this is our temporary, what we do. Local as temp end case. And we can load 32 into this slot in this branch because it's just a temporary register. It doesn't matter what we put in here. So this can stay in the delay slot. That's okay. Okay, so this gives us the next index, right? This gives us the next index. What would be nice? What would be really nice would be Load word. It would be really, really cool to have a load word where we could give it another register instead of an offset, right? That would be cool if that offset could be a register, but we can't do that. We can't do that. That's too clever, right? That's that doesn't work. So what if we say, when we do this, what if we just say, so this is going to start at 0. This is a really big change to make here. Actually, hold on. That's not our constant. What we want to load here is 0. And T1 now no longer has a purpose. So T1 is now free to use. So maybe T1 should actually be the chest table offset, right? Okay, so because we don't want to have to load that all the time. So now we do this, and where we used to store this half word, before we do this, we want to say, hey, get the next thing. So let's actually do it up here, right? Let's say jump and link get jump and link, it's called get next chest index. Next chest index. Okay? Let's see if this works. This might be a freaking disaster. And if it's a disaster, I'm not going to have time to fix it because I've got to go, hang out with my parents and stuff. They're in town visiting. Cool. Okay. We can do this add here. That's okay. I guess I'll put a not just to be safe. Next chest index. So now we have a chest index. The thing we really want to do is put into T1. We're going to add IU T1. We're going to add T0 to T1, right? We're going to go from an index and a memory address to, crap, except we now need another. We'll put that in T7. We'll put that in T7. Because T7, it's fine. It gets overridden. That's no dramas. No drama. No skin off my back. No skin off my back at all. No skin off my teeth. Now, when we get down here, T7, so we need to do this differently, right? We need to say load T2, that's all good. So we can say after, let's do it before this. Let's jump and link next chest index. And now we need to do the same thing where we add T7, we add the index to the thing, and we store the half word there. Now we need to do this a couple of times. Maybe this would be better like in a loop, I don't know. So let's actually just do this. Except instead of loading the thing, now we're just gonna, and we don't need to do this add anymore. So that's good. Okay, next chest index. Instead of this, we're gonna say add IU T2, we're gonna add 10. And I should have copied and pasted this, but that's okay. You live and you learn. Okay, so now here again, we use T0 like this, but that's not what we're doing anymore. We need to get rid of anywhere we add on to T0, because that's now done in one central place. We get a random number. Let's jump and link to this first. Next chest index. This is now, T0 has been updated. We're gonna not here. Yeah, these have to, because T7 is gonna get overridden by this. So T0's been updated. We do all of this stuff. Now we add IU T7, T0, T1, and we store this at T7. Okay. And now we don't do this either. What happens if I build this? What happens if I build this now? Operand 3 must be an immediate expression. Ah, yes, of course. I'm trying to add IU something that's not add IUable. This is just an add. This is just an add. It's okay to just add. Not everything has to be this is an add IU, but this is just an add. This is just an add. This is just an add. Oops, that's not make B anymore. I'm not doing go. Words. Unknown pseudo-op. Words. Word. 0 more expression separated by commas. Okay, this is just word. One of those adds. Oh, Mr. U. That should be okay. I don't need to add U. That's fine. Okay, so I see nothing that could go wrong if I compile and run this now. There's nothing that could go wrong. This will be fine. Let's see. Let's find out. My concentration is starting to waver. Oh, I left it as add you instead of add. That is actually fine as well. No plan survives contact with the enemy. Yeah, this is it. This is, I mean, not quite running on metal, but, you know, the closest thing. So let's see what happens. Does this blow up? Does the game still even run? This is, if you do this badly, this happens. The game hangs. You get a black screen. Yeah, so add you versus add, right? It's just it's unsigned, and nothing I'm doing should care if they're signed or unsigned. They're small enough numbers. So let's just throw the debugger at this and see if I can work out where this is blowing up. We're gonna break on my little hooked code. But I probably am gonna have to go have lunch and make a move in a sec. Okay. So this all looks good. What happens after we jump and link here? Ah, we loop forever. Beautiful. Can I reset? Yes, okay, that's good. That's very important. Let's step into that code and see if we can work out what went wrong. So we jump and link here, step into. Let's have a look. So we add 1 to T0, T0's 0, that's cool. T1 is the address, that's also good. So we add 1, that's good. We set T7 up to be 1df. What's 1df? What's 1df? Hold on. Oh yeah, 1df. That's right. That's right. We subtract, and if it's yes, cool. We're fine. We're fine. FF000. We're gonna run as soon as we hit my breakpoint. Still quite new to MIPS ASM. That's okay. So am I. So am I. We're all learning together. Run jump to cursor. No, that's not what I wanted. Oops. Where am I? Where'd I go? No. Hold on. We need to restart. I did it wrong. That was silly. I think it was F120, right? Yeah, 120. So let's get to here. Add store word, jump and link F120. Okay, so let's put a breakpoint here for future reference. So we do the subtraction. What's in T7 after the subtraction? 1D. Perfect. ETA on a Rust VM stream. That's okay. I mean, look, you're welcome to share thoughts. People have been leaving really helpful YouTube comments as well. That's also a good place to get my attention. I think I have done with my box dyne issues. I think I worked it out. I think I was just trying to build the wrong abstraction. But probably this coming week, I will do more Rust stuff. I'm not going to be stuck on this for too long. This has been an ongoing project for like months. Also, yeah, Discord. I've got a Discord. Hold on, let me link my Discord. I like linking my Discord. Sorry, I had a cool message about Fugitive. Let's create an invite that lasts forever. Oh no, let's just do a short one. Okay. Okay. This is good. Please come to the Discord and the Rust channel. You're more than welcome. You're more than welcome. Okay, so branch of less than or equal to 0. That's good. This is false. Now we keep going. We add. So T7 is 20. We branch if it's not 0. I don't think that's right. Because then we skip the divide. Why is there a branch here? Hold on. Where did this branch come from? Where did that branch come from? Okay. I'm done for today. I'm confused about where a branch came from here. Unless we add AU T7. Unless I do this, right? Let me try this real quick. And I'm not gonna look at I'm just gonna see, I'm gonna throw something at the wall and see if it works. Because that branch was weird. And we're just gonna see. We're just gonna see. And then I'm gonna have to go eat lunch because I'm getting quite hungry and I've got dinner plans tonight with my parents. Okay. It's a black screen. That's okay. That's okay. We tried. We really tried. That branch seems sus. Lots of things seem sus in my code. But yeah, awesome. This has been a fun stream. We've got a couple of viewers. Let's find a cool stream to throw them onto for a raid. Who is looking good? Who is looking good? Retro FPS game dev in Godot. That sounds pretty good. That's my kind of thing. Shut up, late Zymus. I'm sorry. I have been streaming at weird times, but you know, this is what happens. This is what happens. Dev house overworld map. That seems kind of fun. Let's do a retro FPS because I'm a Quake person. Let's throw a raid on. So thank you everyone for hanging out and tuning in. It's been a lot of fun. It's been a lot of fun today. We've had some good people hanging out and chatting. It's always nice. It's always really nice. Let's throw some people on for a raid. Thank you very much for tuning in. As I said, I will catch you next time. Thank you. Bye.